Okay, guys, so all of you are back. Are you there, all of you? Can you see the board?
Yes, sir.
Okay, we were discussing the revolution of the moon and how long does it take for it to make one complete revolution, new moon to the new moon. Correct? Can you see the second position of Earth? E1, E2 and the moon. Can you see that, Keshav? Hello, anyone? Are you there? No.
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
We are coming to the important part now, so pay attention. The first new moon was here. The moon is going around the Earth. We know it takes about 27 days or 29 days. There are two periods we are trying to find out. What is the difference between the synodic period and the sidereal period? During this 27 or 29 days, the Earth is also revolving around the Sun. So the Earth has come here. With 1 month she will be here, 2 months she will be here, 3 months she will be here. Like this, 12 months she has to come back. So the Earth has moved. So now the moon has made one revolution around the Earth and come back to this position when it is pointing to the same spot in space. On the blackboard, the line may look like 2 inches parallel, but when you look at the distances, it is the same. Infinite point far away in space. Have you understood this one or no? The moon has gone around the Earth once, and same meridian, same position it has come. Let us say there was one observer here. There is one observer here. Same position. Is there any difference in the position of the moon?
Sir, but abhi full moon day, new moon day थोड़ा ना आएगा sir.
Yeah, I will come to that one. But as far as the geometry and the diagram goes, this is circle, this is one circle. Has the moon completed one complete revolution of the Earth or no?
Yes, sir.
From the geometry point of it, the moon has completed one revolution of the Earth. This is the correct time the moon has taken to revolve once around the Earth. Am I right? This is called the sidereal period, which is 27 days, 7 hours, 43 minutes and 12 seconds. This is so very accurate. There cannot be a mistake in this. Am I clear on this point?
Yes, sir.
Yes, sir.
The moon has gone around the Earth once. From the geometry of it, we can see everything is okay. But to an observer on the Earth, he has no reference point. His reference point was the new moon, So he is waiting for the new moon because he thinks new moon to new moon, that means the same position has come. But here we are not having new moon because the sun is not here. The sun is not here. If the sun would have been here, then we would have had new moon. These distances are very small compared to that far off distance. So when will we see new moon again? When the sun has, when the moon has come here. We will see new moon when the moon has come to this point. Am I right or no? Because only when moon and the sun are in conjunction will you have new moon. Yes or no?
Yes, sir.
Yes, sir.
So there is this small angle over here which has to be covered by the moon, about 12.2 degrees or whatever. This angle has to be covered by the moon. So it takes a little longer. That longer period is 29 days, 12 hours and 44 minutes. 29 days, 12 hours and 44 minutes. This is called the synodic period of the moon. So if you,
But sir, Earth is also revolving, तो वो थोड़ा आगे नहीं आ जाएगा उतने टाइम में?
कितने टाइम? हाँ आ जाएगा, आने दो. So now if you are thinking
sir,
of
कंजक्शन में नहीं रहेंगे वो?
Pardon?
सर तब वो कंजक्शन में नहीं रह पाएंगे ना, अर्थ आगे आ जाएगा जब.
ये थोड़ा सा और आगे आ जाएगा ना. That's what you mean to say?
Yes sir.
आने दो. We will wait till it is new moon. We will wait till it is new moon. No? So new moon to new moon is synodic period. Yes.
Yes sir.
So you have raised a very important point. Is it 29 days, 12 hours, 44 minutes exact? This synodic period will change. How it changes, I will tell you. We know about all the bodies sometimes being close to the sun, sometimes being far away from the sun. Now tell me, this part is very far away. This part is close. We saw Kepler's law also. So there may be a point when the Earth is here. And this is very close, so the Earth may travel a little more. And then this angle is much bigger than this angle. Yes or no? We spoke about angular velocities. Yes?
Yes sir.
So there may be some periods where the synodic period will be slightly variable. That is because the path is elliptical, it is not circular. If it would have been a circular path, then all the measurements would have been same every month. The length of the synodic period is not constant. You can read the book also. It can have a maximum variation of about 13 hours from the mean value due to the eccentricity of the moon's orbit and that of the Earth's orbit. The variation is also caused by other disturbances which are not beyond the scope of this book. So because the moon is also moving in an elliptical path, the sun is also moving in an elliptical path, there will be slight variations depending upon whether they are close to each other or little far from each other. Actually, it is all geometrical figures. You can easily figure it out. So any questions you have, gentlemen, between these two periods, the lunar month, the synodic period? If you want to know the exact time it takes to rotate once, that is the sidereal period. But for us, it is difficult to understand because when we look at the moon, we say अभी अमावस नहीं आया या पूर्णिमा नहीं आया, एक महीना नहीं हुआ. Purnima to Purnima is 1 month for us. New moon to new moon or full moon to full moon. So those days are slightly variable than the actual sidereal period. Are we clear on this topic, gentlemen? Yes or no?
Yes.
ये sidereal period एक बार फिर बता दिए.
Sidereal period is the exact rotation. I will just try to explain you. Sidereal period, if you look at the definition in the book, is the period of time taken by the moon to make one complete revolution of 360 degrees around the earth. The sidereal period of constant duration. Now, if I am able to have a geographical point fixed somewhere on the moon, let us say there is one spot on the moon which I can see, the red spot, and there is one observer here. So when that spot exactly comes over my head, or I have got some means of verifying that, okay, I can see that exact spot at the same point now, that means 360 degree it has turned. But because our reference point is the sun, in the sense we are observing the moon from the angle of new moon or full moon. So when the moon comes back over here again, we are not able to have the new moon because the sun is not in line with that, not in conjunction. The sun is still on the side. So unless and until the moon comes in line with the sun again, we will not have that new moon. Here all three are in one line. Here all three are in one line, but not at this point. So if you are taking the reference point as the sun, the background, then there is a slight difference because the earth has also moved here. But if you are taking the reference point on the moon, if you have got some means of checking that yes, I am seeing the same point of the moon as I did earlier, then that 24-hour period or that one complete revolution will be in this point. Have I been able to make you understand better now or no?
Yes, sir.
If you
Yes,
have
sir.
got an idea, and if you see, I will not say that you will be able to understand everything in the first instance because you need to think about it. You need to imagine also. That's why I always say, whatever is being done in my class, go and read once again. Try to figure out yourself and read once and come to my class. Then you will understand better because sometimes, it will take you half an hour, 1 hour to understand one particular concept. So in the class, sometimes all students may not get exactly the same thought process which I'm trying to convey. Some of you I'm seeing are able to understand much faster, and some of you are even replying to what I have not said. That means they have read something about it beforehand. So there is a slight difference between the responses which I'm getting. So no problem. Others who are not able to respond now, read a little more. So you will be able to understand. It's nothing much difficult. But why I'm spending a little more time on this, because all these things are setting the background for your other sessions later on or other classes or practical or whatever. Right, gentlemen? So let's move on. Let's go to the nodes, ascending node and descending node. I will show you a picture from the book now. Spend a few moments over there and then we will discuss about the phases of the moon. So I'll just switch off the camera and share the screen. Are you able to see this picture now? Nodes?
Yes, sir.
Okay. You see, this is the celestial sphere, the bigger circle. Q dash is the equinoctial. The sun is going around the path EC, ecliptic. EC, the bold line. And the dotted line OO dash is the path of the moon, as we see on the sky. As we see on the sky. You will see that the path of the moon is slightly different from the path of the sun, in the sense that the declination is a little more. Q dash C is the maximum declination of the sun. Q dash O dash is the maximum declination of the moon, either side. And there are two nodes, ascending node and descending node. We need to know this because when the eclipses take place, when the eclipse takes place, it is sometimes, it has to be during the nodes. So let me just read out over here. The points at which the moon's orbit intersects the ecliptic are called moon's nodes. That mode at which the moon crosses the ecliptic from south to north is called the ascending node, and the other one is called the descending node. The nodal points are not fixed points on the ecliptic. They move westwards along the ecliptic by about 19 degrees a year. Now, this point which you see over here, this point, Iris, you can see my cursor moving over there. This cross over here. Yes?
Yes, sir.
That point of Iris is not fixed because the moon is also revolving, the earth is also revolving, they are all moving as a combination. I told you the path is complicated. While the ecliptic remains where it is, these nodes, this is slightly moving. What does it say? They move westward along the ecliptic by about 19 degrees a year, not along the equinoctial. So this cross, the moon's path and the sun's path, which is crossing, it will cross on this bold line, moving westwards by about 19 degrees a year. So Iris to E, you can see this bold line, Iris to E. Yes. Shall I draw on the board?
Yes, sir, board.
Yes, sir.
I had a feeling that you can see the board and my shared screen together, by toggling, would that not have been simpler instead of me changing then I think spending a lot of time? Can you people not do that? Toggle between the camera and the shared screen. Is it easier for you or no?
No, sir.
Anyway,
No.
the sun is on this point, that is the ecliptic. And the moon is on this point. And this is the path of the moon. The point of reference, what we are talking about this, ascending node and descending node, what it says the first point of Iris. Because of the movement, the complex movement, this point is moving westwards by 19 degrees a year along the ecliptic. That means this point is moving like this. Every year it will move 19 degrees here. So the path of the moon will be like this. Every 19 years it will go on moving like this. Is it understood now? Yes or no? This will be the path of intersection after every 19 years. So this path of the moon, it is turning like this. Yes?
every 19 years the declination change.
Every 19 years, this point will be
Maximum
here.
declination.
So it is shifting little bit slowly every year.
Okay, okay.
So what does the thing say? The nodal points are not fixed points on the ecliptic. They move westwards along the ecliptic about 19 degrees a year. So every month they must be moving about 1.5 degrees. Yes?
Yes.
Yes, sir.
19 degree in 1 year. So the nodes therefore complete a full cycle of the motion around the ecliptic in about 18.6 years, which means these nodes also keep moving along the ecliptic, and after 18.6 years we will find the same situation again. 18.6 years we will find the same situation here again. Not a very relevant thing for you, but just for you to understand that there is a movement along that line and these things are shifting. So as an awareness, you should know what is the movement and how it is happening. Some people who are very sharp, they can even notice all these things in the almanac. By looking at the almanac, they know why this is happening when you're taking readings every day. But nowadays, of course, you don't do sights and all. So if you are doing sights and doing manual calculations every day, then you can immediately figure out what is happening. Nowadays, I think everything is on your Excel sheets and things like that. Okay, so I will switch off the camera and come back to the screen. Can you see the board now? Oh, sorry, I had to come to the screen. Okay. So try to arrange that, gentlemen. If you can toggle between my camera and my screen sharing, because that is what I was told, that if I do that, it will be easier for the students also. And for me also, teaching will be a little easier and faster because I can switch on between the both. You can see the screen now?
Yes,
Is
sir.
my shared screen visible now? Okay. So when the ascending node of the moon coincides with the first point of Aries, as shown in figure 7.2, the inclination of the moon's orbit with respect to the equinoctial is equal to 23.5 degrees plus 5 degrees. That is the additional, we are seeing the declination. So the maximum declination of the moon, north and south, would also be the same value. After 9.25 years, because we said 18.5 years, 18.6, When the descending node coincides with the first point of Iris, the inclination of the moon's orbit to the equinoctial would be 18.22 degrees approximately. On the other side, it will be less, because you can see in the ascending node, the declination is increasing. So Q dash, O dash is about 23 and 5, about 28 degrees. But if you go on the other side, the declination starts decreasing also. Let's come to phases of the moon. We spoke about new moon and full moon. In between, what happens? Does it like a bulb switch off, full moon and new moon, or it goes through different phases? Yeah, gentlemen, does it happen suddenly overnight, in between nothing, or does it happen slowly?
Slowly.
Slowly, sir.
Yeah, it is not like that. No, today is new moon and tomorrow is full moon. Suddenly in between we don't say. We see the moon is increasing in size slowly till it becomes full moon, and then we see it decreasing in size slowly till we get the new moon once again. So the increasing in size is called the waxing, and the decreasing in size is called the waning. I will show you a video on this, so it will be much more clear. But are you able to see the diagram on the screen? I will explain on the diagram first. Yes?
Yes, sir.
The Earth is in the center.
Yes,
The Earth is in the center. Going, we are seeing from the top, so rotating anti-clockwise. On the right is the new moon, and further right is the sun. So sunlight is coming from the right side of the page. When moon is at the position new moon, then what is happening? In the earlier diagram on the board, we saw that part of the moon is illuminated, but the part which is the hemisphere which is facing the Earth, what is happening over there? It is
dark.
Dark. So that is the new moon. Moon is in conjunction. Look at the opposite side, full moon. Now the Earth is in between the moon and the sun.
Moon and
So which side of the moon is getting illuminated? The one which is facing the Earth. So we see the full moon. So these two pictures are clear to you? New moon and the full moon?
yes, sir.
We already saw on the board. I had drawn this diagram. So now what happens in between? In between
So
we will see.
moon's path on Earth is taken circular.
What should it be?
Elliptical.
So I told you know the slight difference. How does it really matter? Circular or elliptical? It depends what situation we are looking at. Here I'm not making any fine calculations, so it doesn't really matter to me. I know it is going around the Earth. This waxing and waning will, now I'm assuming the Earth to be stationary. Earlier I said Earth stationary, Venus moving. So we have to imagine so many things also. You can take it as elliptical, it won't really make a difference. So there will be one situation where it will be in conjunction, new moon, and there will be one situation where it is in opposition, full moon. Am I right? That really won't matter whether we call it circular or elliptical. Now in between the new moon and the full moon, you can see on top of the picture, the size will increase, which is called waxing. We discussed three situations: crescent, first quarter, gibbous, And between the two circles, you can see the shape how it will look. You can see the shape how it will look. The first one is a crescent, you can see. Yes.
Yes, sir.
After that, it increases in size to half. After that, it increases a little more. It is bulging on the other side also. We call it gibbous. And then there is full moon. Yesterday was full moon, Budh Purnima. So you must have had a look at the moon. Now keep watching the moon every day if you can, and try to relate with these pictures. There is a very interesting fact. After full moon, when the size of the moon starts reducing, it is called waning. It is called waning. You will see first it will become gibbous. Then it will become half again, third quarter, again a crescent, and then again a new moon. One interesting point to note here is the side, the bulge of the moon is changing. The side which is facing the sun is illuminated. The side which is facing the sun is being illuminated. If take a look at figure 8. Take a look at figure 8. If I continue the crescent in the same direction, is it matching with the figure? The first crescent on top just below 2. Will it continue in that shape or no? You see, in the first crescent, the curve is pointing down. In the second crescent, the curve is pointing up. If I just shift that figure number 8 to figure number 2, it is a mismatch. Am I right? Yes or no?
Yes, sir.
Only one answer. Every time I get only one answer. So the shape of the crescent you must note. Which side of the horizon it is. When you look at the sun, for 1 month, do this practice every day. Look for Venus, look for the moon. Which side is rising, the crescent with the curve on top or the curve bottom? Which side is rising? You will notice that from new moon to the full moon, maybe the crescent is pointing down. And from the full moon to the new moon when it comes, the crescent is pointing in the opposite direction. So keep this as an exercise and watch the moon how it goes. So we'll move on. This is quite an easy and a simple topic. Waxing and waning of the moon, different phases of the moon. The phase is also shown in the almanac also. I will just take you down to the almanac and I will show you. So read this topic. It depends the age of the moon. Is the time of period elapsed since the new moon? I will just take you down to the almanac. There is one column over the age of the moon or the phase of the moon. It is the time period elapsed since the new moon, not the full moon. So this is page 104. I will just quickly take you down. Yeah. You see here the phase of the moon. Bottom right. Age 19 days, 20 days, 21 days. 20 days, 20 days from new moon. No? The age starts from the new moon. That means it is going towards the full moon now. It is gibbous position. And then it will become 28 days, 29 days, it will become once again. Sorry, it is 1921 days from the new moon. So once again, it will become the new moon. No? It is going towards the crescent side. Let us see if there are other pages. No. Actually, very few pages. The extract is only given. This is 29 days from the new moon. So once again, it is full dark. The dark is the portion which is being shown as the moon, not the bright portion. So in this one, you could see the crescent, how it is, because it is approaching new moon now. Let me see if there is a smaller age of the moon. Yeah, this one. This one is on different side. If you have the full almanac, then when you leaf through the almanac, you can see the sequence, how it goes. So we'll come back to another topic.
Sir, this age means like it is given 20 days or 25 days something. So it means from new moon, it has traveled around 28 days.
Yeah.
And the figure which is given, what does that mean?
Yeah, the figure is the shape you will see the moon in.
After that age period or like?
After the new
Right.
moon. You see the definition on top over here on the screen now. The age of the moon is the period of time elapsed since the last new moon. Since the last new moon. Because there has to be a reference point always. We will forget all these things, harvest and all. We'll come to the daily retardation of the moon. There's one more very important aspect of the moon. Does the moon rise at the same time every day?
No, sir.
No, sir.
What about the sun?
No, sir.
No, sir.
The difference between the sunrise every day is how much? Half a minute, 1 minute, like that? Have you noticed?
Yes, sir.
Sunrise time is also given. But in the case of moon, it is too much, 50 minutes every day. At new moon, the sun and moon are in conjunction because they're in one line. They will culminate at the same time. Culminate means coming on the meridian. During the course of the day, the moon would have moved eastwards by about 12.2 degrees in its orbit around the earth with respect to the sun. Exactly 1 day after new moon, when the earth has completed one rotation of 360 degrees with respect to the sun, the earth has once again culminates, but for the moon to culminate again, the earth would have to rotate a further 12.2 degrees since the earth rotates at 15 degrees per hour. It takes about 49 minutes to rotate the further 12.2 degrees. The moon culminates about 50 minutes later each day. If the declination remained unchanged, it would rise and set approximately 50 minutes later each day. The average length of the lunar day is therefore about 24 hours 50 minutes of mean solar time. You want me to show this on the board? It will be easy for you to understand.
Yes, sir.
Okay. I'm seeing if there is any diagram over here or not. In some other book there is a diagram. Okay. Try to figure out if you can toggle between my camera and the screen. It will make everyone's life easier. Can you see the board now? Okay. So this is the sun over here. This is the earth. And this is the moon. So we have new moon now. Agreed? Yes or no? Now
Yes,
let us say after one day, there is an observer here. The earth has rotated and come back to the same point. What happened to the moon in the meantime? This is not 24 hours. I'm not talking about the month. In 24 hours, the earth has rotated. An observer, he has got some method of knowing. He says, I have completed one day. What has happened to the moon?
sir, in globus position.
The moon has also moved a little bit because the moon also has to take about 28, 29 days to go around the earth. Yes or no?
Yes.
Yes, sir.
The moon has also moved a little bit. Now the question is how much the moon has moved. The calculation shown in the book is for the moon to complete this 360-degree revolution is taking 29 days. So every day the moon is moving by how much? About 12.2 degrees. Calculate and see on a calculator. 12 3s are 360, no? So about 12.2 degrees the moon has moved away. Which means what? Are you having calculator in your hand?
Yes, sir.
Yes, sir.
Yes, sir.
So by this much the moon has moved. So the observer will have to travel another 12.2 degrees before he can say, yes, the moon is over my head. Am I right or no?
Yes.
Yes, sir.
If the observer has made one complete revolution, he finds that the moon is no longer over his head or wherever. He has to travel 12.2 degrees more before he realizes, yes, now the moon has come to my same position over my head. So now how long is 12.2 degrees taking? Calculate. How long will the earth take to turn 12.2 degrees? Can you do it for me? These are simple things, gentlemen. 360 degrees in 24 hours. So 12.2 degrees in. Calculate and tell me.
15.
How much? Be a little louder, I can't hear you. You people are making life difficult. What to do? I can't go back to the book now to show you. How long will it take?
Around 3 hours.
Huh?
Around 3 hours.
3 hours? How?
Sir,
360 degree
0.8.
equal to 24 hours.
48
0.8
minutes, sir.
hours.
0.8, sir.
0.8.
Give me in minutes.
48 minutes. 48.8 minutes.
49 minutes. That is what the book is also saying, no? 49 or 50 minutes approximately. Again, this will slightly vary, because the paths are all elliptical paths. They are not circles. Somebody said path is elliptical, you are showing circle. I am not showing anything. We are just talking out of convenience so that it's easy for you to understand. If the path is circular, it will take exactly 48.8 minutes, but the path is elliptical, so sometimes 48, sometimes 49, sometimes 51. Because the circle is not perfect, no? So this will be slightly moving in a funny manner. So after 50 minutes, the sun will be over his head. Sorry, the moon. Am I right? Because the earth will take another 50 minutes because the moon has already gone ahead, no? The moon has already gone ahead a little bit. That means it will rise also 50 minutes later.
Yes.
If it is taking 50 minutes more to come to the same position. So if my rising was today at 6 in the evening, tomorrow rising will be what? 6:50.
Yes.
The next day rising will be again 7:40. Because the earth has to rotate a little more to come to the same position. Am I right?
Yes.
Yes, sir.
So here it is showing over the head. I can put the observer here. Because this part is dark, we know that. I can put the observer here. And I can say moonrise. I can put the moon here. Then you will understand better I'm talking about the moon rising. Because this part is dark. So second part of your exercise, when you are observing the shape of the moon every day from today, observe the time also at what time you can see the moon at the same point. Maybe you are staying in a city, there are buildings around you, you can't see the moon rise. But fix one reference point from your balcony or from this point on the road or from that point on the window. You saw the moon exactly at this position over here today. Tomorrow you see it will not be there at that same time, same position. It will come 50 minutes later, 50. So will you do that for me?
Yes,
For you
sir.
to understand better. For
Yes.
you to understand better. Okay. So we come to the next point. Now, what I will do, actually I wanted to touch eclipse also today, but
Sir, we can revise this all.
but we are going a little slow because moon is a little complicated. So there are two more small topics like daily retardation of the moon I have done. Appearance of the moon relative to the horizon I have told you to have a look. Which side is the curve, which side is the concave side, which side is the convex side. Every day you watch and observe. The liberation of the moon I will do tomorrow and then eclipses I will do tomorrow. In the meantime, I will just show you a video so that the phases you will understand a little better and maybe some other points also may come in. So shall we do that? There is still, we have about 5-7 minutes. The videos are not very long, same 5-minute videos.